Okay, so I wanted to do a question that can be quite daunting. Um, so it's a triangle with a square that is 1 meter above the ground, and this is 45 degrees. This is 15 kilograms, and there's a pulley here. It's pulling it. And the question is, how much force would be required to move this forward 2 meters? Okay, so there's quite a bit of information that we get at first, but we can actually just separate this into different parts.
Okay, so now we can just ignore the pulley and the friction. And the reason we can do this is because we can just incorporate them into it later. It's really just simpler if we just find out how much force it would take on a frictionless surface without the pulley to just push that square up. And then later on we can reincorporate the pulley and the friction, and we can change our answer from there. But for this video, we're just going to find out what it takes to move the square up that triangle without a pulley or any friction involved.
We can just write, so we can just draw a triangle with the square on it. Okay, and we know that this is 1 meter up. It's going to go to 2 meters, and this is 45 degrees. So let's just find by doing this, we can find out what the potential energy is at the point that it's going to. So 2 meters ahead of where it is, and the point where it is. So, and then we can compare those potential energies. So the potential energy of the square here, and the potential energy of the square here. And then we could subtract this potential energy from this potential energy to see what the difference is and how much energy you have to put in. Okay, so moving on from there, how are we actually going to find out the potential energy? Well, let's just draw this square on the triangle again, more zoomed in. Okay, so this is gravity, right? Or sorry, the force of gravity, so that's going to be mass times gravity. So that's 15 kilograms is the mass. So that's the force that's going down. Now, what happens here is you can actually draw a triangle to represent the forces. So one of them is going in this direction, one of them is going in this direction. Or if you want a bigger version, because that's hard to see, this is this would be mass times gravity. This would be your force downward, so like the actual force on the slope. And then this would be the force against the slope. So we're trying to calculate what this is, right? Now, it's a rule that this angle right here is equal to this angle. Now we know this angle is 45 degrees, so this must be 45 degrees. So now we can really find out what this force is, the force going downwards on the slope. Okay, so we basically have to say sine of 45 times mass times gravity. So let's just pull up our calculator and do that. Okay, so let's go. Sine of 45 times 9.8, that's the acceleration of gravity, times 15 kilograms. Whoa, okay. So we get 103 let's just round to 104. Okay.
So we get that the force downwards on that square is 104 joules. Okay. So what that means is that the potential energy at the initial point is going to be 104 joules. Now, if we find out what the potential energy at the second point is, then we can find out what the energy is required to move that square up 2 meters. Okay, so now we can find out what the potential energy at the second point is. So let's just redraw it, and let's just say what would a square look like if it was 3 meters above the ground. So that's what it would look like after it was moved 2 meters. Okay, so let's just write 104 to remember, and yeah, So we know that it's still going to be 104 because it has the same angle and it has the same force of gravity, but now it's 3 meters. So it's 104 times 3 gets you your amount of joules. So it's 3 meters instead of 1 meter now. So it's the same force, but the amount of work has changed. So now you multiply it by 3, not 1. Okay, so now we can just say that it's going to be 312. So it's 104 times 3 is 312. And now the difference between them, right? Because we have to find out what the difference in energy is. So 312 minus 104 equals 208. So 208 is the difference, and that's how much energy is required to move it up, not accounting for the pulley or the amount of friction. Later we will account for this, and it will change our answer. So quite a bit, actually. So thank you.